Good evening, students. Today we will discuss about the question from scale diagrams in your paper. And in this question, there are a few things in some theoretical things we should know before we do the paper. So if you know these things, the question in your paper will be very easy. So this is a question that you can easily get the full marks. So let's discuss what are the things we should know about these scale diagrams. Okay. Okay, in here I have prepared a PDF so we can easily get through the notes we should know. Okay, so in this question, Pute, I know that you have seen some words called elevation and depression, angle of elevation and angle of depression. So in the question, they will give you an angle. This is the angle of depression or this is the angle of elevation and include that data in the given diagram. Such questions will be there. Okay, so you should know what is this angle of elevation and what is this angle of depression. Now let's think uh, there's something above our eye level. Okay, there's a bird flying in the sky. So when we are looking at that bird, we can see uh, from our normal eye level, we have to look at the sky, right? Now, in here, I have drawn a figure. We can see there's a point called A. I have taken it, and this dotted line you can see that is the eye level. Now, let's see. Amal is at the point A. Now, AB is a vertical building, and on top of that, Amal is there. Now, normally, when we are marking elevation and depression angles, first we have to mark the eye level. That means the horizontal plane level, we have to mark with a dotted line. Okay, so from starting from the eye level, always we have to describe the angle of elevation and angle of depression. Okay, starting from the eye level, always we have to start from eye level. Now, this is the eye level of Amal. Okay, then according to this one, now if Amal is looking at the point D. You can see this is his eye level, and from here to here, right? He has to look at D from here to here. So the magnitude of the rotation of this angle from starting from the eye level up to point D, this magnitude of this angle is called as the angle of elevation. Okay, so the angle of elevation of Amal when looking at the point D is 30 degrees. Okay, so elevation means Pute, always we are looking at something above our eye level. Then, what is mean by the angle of depression? That means we are looking at something that is beyond our eye level. Okay, now let's think here there's a cat. Now Amal is on the building and here's a cat. Then if Amal is looking at the cat, now this is his eye level. From this eye level, he has to look down, right? So from the eye level, what is the magnitude of that angle? That is called as the angle of depression. Yeah, so those are the two things we should know about angle of elevation and angle of depression. Elevation means normally we are looking at something above our eye level, and depression means that is beyond our eye level. Okay, then I think it is clear enough. Then let's move on with the next thing. So in this question, there's something called bearing. So bearing means now normally angle of elevation and angle of depression. These two things we will use with vertical plane. That means with the vertical buildings and vertical trees like that. Then when we are considering the angles from a top to another top or from a top to the bottom, those are the vertical plane locations. So in such instances, we have to use angle of elevation and angle of depression when we are talking about the locations of such things. But when we are talking about the locations of the things with the same plane, on the same horizontal plane, we have to use the word bearing. Okay, now let's think there are uh, two friends called X and Y, and now I need to explain the location of Y using the location of X, or else with respect to the location of X. Okay, so in that case, we can use the north direction of X. Now I'm gonna express the location of Y using the location of X. So if I'm going to explain it using the location of X, that means I have to consider the north direction of X. That's what I have marked in here. Okay. So now you can see I have joined these two points, X and Y. Then, starting from the north direction, what is the magnitude of this angle up to this line? That is what we will take as the bearing. Okay, so when we are writing a bearing, there are some conditions. Bearing, when we are writing it, first we have to measure it starting from the north direction of the respected location, north direction. And always we have to get the bearing in clockwise direction. That is the next condition. Then the third condition is always we have to use 3 digits to express a bearing. Okay, now you can see when I'm describing the location of y or else the angle I have to rotate from x. I have started it from north direction of x and the clockwise magnitude is 50 degrees. Then I can write it as bearing of y from x is 50 degrees. Now you can see I told you bearing means always you have to use 3 digits. So that's why I have used another 0 in the front of 50. Okay, so in your paper, there will be something about bearing like this, and always, if it is not like this, bearing of y from x, or else they can mention it as bearing of y with respect to x. Okay, so we have to take, if it is respect to x, we have to take the angle of x starting from the north direction of x. Then what about the bearing of x from y? Now, from y. So we have to check it with the north direction of y. Okay, with respect to y means we have to start it from the north direction of y. And I told you, if it is a bearing, always we have to take the magnitude in clockwise direction. Now, starting from the north direction Pute, to meet this line, I can't rotate it in this direction. It is anti-clockwise, right? Clockwise means I have to take this rotation. So this will be a reflect angle here. So that is why I have marked it starting from north clockwise direction, that is 230 degrees. Then I can tell it as the bearing of x from y is 230. This is the right angle side, the side in front of the right angle. Here this side, always we call it as the hypotenuse. Okay, always we can call it as the hypotenuse. Then, now when we are using these ratios, Pute, except this right angle, we have to use another angle in this triangle. Except this right angle, we have to use some other angle. From this one or this one, you have to select one of them. Then, now I have taken this one as theta. Theta means this is a symbol I use to identify, denote the angle I'm using. Okay, now this is the angle I will use. Now, according to that angle, we have to name the others two sides. Okay, now already we know that the side in front of the right angle, that is the hypotenuse. Then what about this one? The side in front of the selected angle. The side in front of the selected angle. That is what we call as the opposite side. Okay, the side in front of the selected angle is known as the opposite side, and the side with the selected angle, except the hypotenuse, the side with the angle, we can call it as the adjacent side. Okay, so those are the 3 sides. We should know how to name the sides corresponding to the selected angle. Up a ratio between the magnitude of this selected angle and 2 sides of the triangle. Those are the ratios we are using as sine cos tan. Then what is sine theta? Theta means I told you we will select an angle, then we have to get the sine value of that angle. Okay, sine value of the corresponding angle. Now let's think, in here it was 30 degrees, then here we had to write it as sine 30. Okay, so the sine value of 30 degrees. Then that is equal to the opposite side divided by the hypotenuse. That means the sine ratio is given by the opposite side divided by the hypotenuse. Okay. Now according to our triangle, I have taken it as sine theta equal. So what is the opposite side? This one. That is AB. Side AB. So AB divided by the hypotenuse is side AC. So AB divided by AC. Using this one, the length of AB divided by the length of AC, we can find the value of sine value of that corresponding angle. Okay. Then what is cos theta? Cos theta means the cos value of the corresponding angle. So in that case, we have to use the adjacent side and the hypotenuse. Cos theta equal adjacent side divided by the hypotenuse. So in our diagram, the adjacent side is BC and the hypotenuse is AC. So we can write it as cos theta equal BC divided by AC. So when you are dividing the length of BC by the length of AC, you can find the value of cos theta. Okay. Then what is tan? Tan theta we can find by dividing the opposite side length by the adjacent side length. The opposite side is AB, the adjacent side is BC. That means if you divide the length of AB by the length of BC, you will get the tan value of that corresponding angle. Now you should know in here sine theta, cos theta, or else tan theta is not the magnitude of the angle. Those are the sine, cos, tan values of that angle. Let's talk about a small example regarding these theoretical parts. Now, I have given you a small example here. You can see. Now, in this question put there, this diagram is given and I'm asking you to find the height AB. This AB height, this side length you have to find. Okay. Now, if it is a right angle triangle, even you can use Pythagoras theorem, right? In here also, you can use Pythagoras theorem and using midpoint theorem also, you can find the length of AB. But now, since we are talking about scale diagrams, I will use the scale diagram theories to explain how to obtain the AB value. Okay. Normally in that question, all your paper, in the question, they will mention it as find this length or else find this angle using trigonometric ratios. In that, whether you solve the problem using any other method, the marks will not be allocated. Okay. So let's see. Now, I told you always sine cos tan means the relationship between an angle and two sides of the triangle. Okay. Now, since we are going to find this side of the triangle, we should know an angle of that triangle and another one side of that triangle. Okay. Now, AB side belongs to the triangle ABC. This one, right? So, in this triangle, we should know an angle. Now, except this 90-degree, I haven't provided any angles here, right? So before you find AB, then you have to find one of these angles. Okay, that's why I have marked this angle as theta, or else you can use this one also if you wish. Okay, now let's find theta. So how can we find theta? Again, to find theta, we should know two sides of the corresponding triangle. Now theta is in this triangle and also theta is an interior angle of this smaller triangle, right? So when we are considering this small one, we can see two sides of that triangle is given, right? Two sides are given. So using those two, we can find the value of theta, right? Then here, now I told you before you solve this one, before you use sine cos tan, first you have to identify the sides, right? So the side opposite to the right angle, this one, it is the hypotenuse. Okay, and side in front of the selected angle is opposite side. Okay, now we are going to use the opposite side and the hypotenuse. Since we don't know this adjacent side, we can't use that one. So we had to use these two, opposite and hypotenuse. Then using those two, among these three, which one we had to take? Opposite and hypotenuse means sine, right? So we had to take sine theta. Here instead of theta, you can use any variable. Okay, so sine theta equal, now what is the opposite side? 3 meters. Then 3 divided by, the hypotenuse is 4. So 3 divided by 4. So if you divide 3 by 4, you will obtain 0.75. Then now this is sine theta. I told you, Bude, this is not the theta value. This is the sine value of that corresponding angle. So we have to find the theta, the angle, magnitude of the angle. Then this one should be not sine theta, it should be theta equal, right? Then when we are taking the corresponding angle, in here we have to get the inverse, sine inverse value of that corresponding value. Here we got 0.75, then we have to take sine inverse 0.75. And why did I add 200? Normally in sine table, I think you have seen those table. Okay, in those table, in sine tables, in this decimal part, there are 4 digits. That's why I use another 2 zeros in the end of this one. So we have to find sine inverse 0.7500. So how can we find this one? We have to use this sine table. Okay. Now you can see this is the sine table. In here it is mentioned as natural sines. Now we are going to find not sine. We have to find the sine inverse. Sine inverse means always that value 0.7500. You have to check where is it among these values. Okay, so 0.7500. You can see in here you can find 0.7509 is there and 0.74490 is there. So from these two, now we need this one, right? What do we need? We need 0. Sorry. We need 0.7500. But in here we can see it is 0.7509. That is more than this one. So we can't use that. So we have to select this one, 0.749 and 0. Okay, 0.7490. Then now we can check what are the values corresponding to that one. This is 40. In here it is 48. That means Pute, this angle is 48 degrees. And how many minutes are there? 48 degrees. And here the corresponding minutes 30. Okay. But not just 30 minutes. 31 or 32 or 33 or likewise. We have to find using the remain of this, using the difference of these two values. This is what we needed and this is what we got. So what is the difference? Here 0, here 1 and 0, 0, 1. That means 10 remain. So along this same line, we had to check 10. Here 10 is here. That means 5 minutes. So when we are taking the sine inverse, we had to add this 5 minutes with this 30. So that is 35 minutes. So altogether 48 minutes, 48 degrees and 35 minutes is the answer. So that is how we will check sine inverse, cos inverse or else tan inverse. In this table, you can see this sine table. Using the sine table, we can find sine values and also cos values. You can see the lower line. This is what we will use when we are finding cos values and cos inverse. This one and this line. Okay. Then if it is a sine value, we have to use this line and this. Okay. Then to find tan values, there's another table. So using that table, this line and this line. Using those two lines, we can find tan values. Okay. Okay, I think now it is clear enough. How can we find sine values? Now, why did we find this theta? To find this AB. If you need to find this AB, you should know one of these two angles. Now already we took this value, right? Now we will find AB in this large one, right? So according to this large one and this theta, what is this side? Again, this is opposite side of that triangle, the large one. Okay. And the other one, I told you we need two sides. We are going to find this one and we should know another one side length. So this one is the hypotenuse of that triangle. And since these two sides are equal, this one also 4 meters. Okay, then altogether it's 8 meters. So opposite over hypotenuse means sine theta. Then again, let's use sine theta equal AB divided by 8. AB is the opposite side. 8 is the hypotenuse. Then sine theta, again, no need to find. Already we got here sine theta equals 0.75. You can use that value. And if we take this 8 into this side, it will become a multiplication. So 0.75 times 8 equals to AB. Then when we are multiplying these two, we can obtain AB equals 6 meters. So in this question, this is a small question I have built up to explain how to find the values using sin cos tan.